This is TechCrunch.
Commonwealth Fusion Systems, CFS, marked a major milestone Tuesday morning, announcing the installation of a key component of its Sparc demonstration reactor. The new part is a 24-foot wide, 75-ton stainless steel circle that forms the foundation of the tokamak, the donut-shaped heart of a fusion reactor that CFS hopes will be the first of its kind to generate more power than it consumes. Called the cryostat base, it was made in Italy and shipped halfway around the world to CFS's site in Devens, Massachusetts. It is the first piece of the actual fusion machine, Alex Creeley, director of tokamak operations at CFS, told TechCrunch. Work at the site has been underway now for more than 3 years as the company constructs the buildings and machinery that will support the reactor's core. It's a big deal for us because it means we're transitioning into a new stage of the project where we're not building an industrial facility. We're still doing that a bit, but we're also now building the actual tokamak itself, he said. CFS is one of many startups that have emerged in recent years to pursue fusion power, which promises to deliver gigawatts of pollution-free electricity from a hydrogen fuel derived from seawater. Investors have been counting on the technology to meet future power needs, which are skyrocketing as heavy users like electric vehicles and data centers proliferate. The company, which is backed by Bill Gates' Breakthrough Energy Ventures, among other investors, is widely considered to be one of the best prospects to prove whether fusion power is commercially feasible. The company announced in December that its first commercial-scale reactor will be located outside Richmond, Virginia. Sparc is expected to come online in 2027, and if it works as CFS anticipates, it could be the first tokamak to produce more power than it takes to run. So far, only the Department of Energy's National Ignition Facility has been able to hit so-called scientific break-even in a string of successful experiments, the first of which occurred in December 2022. But the NIF's reactor differs significantly from CFS's, using lasers to compress a fuel pellet to fusion conditions. CFS's tokamak uses magnets to herd 100 million degrees Celsius plasma into a tight donut shape, confining and compressing it until fusion occurs. Tokamaks use superconducting magnets to generate the powerful magnetic fields required to corral the plasma. Those magnets need to be cooled to minus 253 degrees Celsius using liquid helium. The cryostat helps maintain those frigid conditions, acting like a thermos by insulating it from ambient temperatures. The cryostat base is basically like the bottom of the thermos, Creeley said. Just like someone receiving an Amazon package, CFS had to unbox and inspect the cryostat base before installing it. But unlike an e-commerce package that takes a few seconds to open, it took the CFS team a few days to remove the shipping material and another week just to make sure that nothing got damaged in shipping, Creeley said. The CFS team then moved the cryostat base to the tokamak hall, where precisely placed bolts protruded from the concrete foundation, awaiting the stainless steel disc. Then you grout it in, he said. Alongside the cryostat base, work continues on the other 3 major pieces of the tokamak, which will be assembled simultaneously into their final configuration either late this year or early next year. After that, CFS will ensure all the pieces are working together as planned, a process known as commissioning, which will take months. This is the first of a kind, Creeley said. There's not just like an on button and it turns on.